Alright, class, let's try round 2 here. So, now, from where we ended off last time, note that the probability of E union F, I'm going to try to type all this, probability of E union F, then, assuming that all the events are equally that each outcome is equally likely, this is going to equal the number of elements in E union F divided by the number of elements in the total sample space. That's going to equal the number of elements in E union F. Let me put a bracket here. Is going to be the number of elements in E plus the number of elements in F minus the number of elements in E intersect F. And that's probably my best way to do an intersection is that caret. Not seeing a better intersection sign. Sorry guys, it's better than my handwriting. So it's the number of elements in E plus the number of elements in F minus the number of elements in E intersect F divided by the number of elements in S. Well, we can break this up into 3 different fractions, and then when you do that, all you do is you get the probability equals the probability of the event E plus the probability of the event F minus the probability of E intersect F. Okay, what did I do here? Point. So this is a big fraction, number of elements in E plus number of elements in F minus the number of elements in E intersect F divided by the entire sample space. So I break this up as this over this plus this over that minus this over that. And then number of elements in E over the number of elements in S is just the probability of the event E. Number of elements in F divided by the number of elements of S is just the probability of the event F. And the number of elements of E intersect F divided by the number of elements in S is just the probability of E intersect F. So the probability of a union is just the sum of the probabilities of the 2 sets minus the probability of their intersection. And so, in a definition real fast before an example, if E intersect F is the empty set, then E and F are mutually exclusive. And in this situation, this case, the probability of E union F equals the probability of E plus the probability of F. And you notice that if E and F are mutually exclusive, then the intersection is empty, so the probability of the intersection is 0. So that's why you just get probability of E plus probability of F. So let's do an example. So for example, one die is rolled. Is cast. Haha. Stick with my thesaurus. One die is cast. E is the event. The number is even. And F is the event. The number is divisible by 3. I know this will just end here. Number is divisible by 3. Now, 2 parts to this. Part A, we want to find the probability of E intersect F. And part B, we want to find the probability of E union F. Alright. So, notice that for A first, that if we want to look at E intersect F, well, we just did this example in the first video. E is the elements 2, 4, and 6, where F is the elements 3 and 6. So we know that E intersect F is just 6. I'll write that. E intersect F is just the set containing the element 6. So the number of elements in E intersect F is just 1. Therefore, since the number of elements in E intersect F is just 1, the number of events in the entire sample space is 6, the probability of E intersect F is just equal to 1/6. So that was not too bad. We didn't have to use anything new there. And now we could do a similar thing for the union. We knew the union had the elements 2, 3, 4, and 6, which has size 4. So you know then that the probability of the union would be 4 over 6. But let's use what we just did a little bit ago. So let's look at part B. We know that the probability of E union F equals the probability of E plus the probability of F minus the probability of E intersect F. Sorry, that's not on a line. It's not too bad. So anyway, this equals the probability of E. The event E is even, 2, 4, 6. There's 3 elements in E, so the probability of the event E is a half. Plus, probability of the event F is the elements of F are 3 and 6, so there's 2, 6, which is a third. Plus, the probability of E intersect F we just did is a sixth, not plus but minus, 1/6. So a half is 3/6, and a third is 2/6. Let me write that out. Equals a half is 3/6 plus a third is 2/6 minus 1/6. And you have 3 plus 2 is 5 minus 1 is 4, so you get 4/6, which equals 2/3. So is that alright? There's nothing too bad there. No. Alright, so now another definition. Two events E and F are independent if the probability of E union F equals the E intersect F, I'm sorry. E intersect F equals the probability of E times the probability of F. In most situations, independent means that the events have no influence on each other. We'll fix this, guys. Sorry. In most situations, independent means that the events have no influence on each other. Let me just check something real quick, guys. Alright, it's time to stop this one.